Alright guys, welcome to the session for today. And is everyone in the meeting? Okay, I can see Nandi there, Richard, everything like that. Okay, that's good. We can now go. Alright, so we are talking about alkanes and cycloalkanes. So this covers industrial chemistry, pure chemistry, pure biology, education chemistry. So this is the major course to say organic chemistry. You need to cover it as all chemist students. Alright, so what are you going to do then? Alright, what are you going to do then? So we'll say we are about to start now. Okay, so we know that alkanes, they obey a general formula. All right, so alkanes obeys a general formula. Okay, so these alkanes, they obey a general formula where we have Cn, all right, H2n like that, then plus 2. We know these are alkanes. Okay, where this number is just a number of carbons. All right, so carbons. Okay, number of carbons, that is it. So these guys, they can be cyclic. All right, cyclic or acyclic. All right, so when I say acyclic, meaning that they are not in a cycle, like, okay, that's acyclic. It's non-cyclic. Okay, so from there, then these guys will be bonded. They'll be bonded into like carbon to carbon like that. They continue like that. So a bond which is just there, it will be a single bond, and this bond will be called a sigma bond. All right, presented by that symbol or just sigma. So a single bond is called a sigma bond. All right, so they are saturated. So let me start with alkanes, explaining alkanes. All right, so alkanes are saturated. By this I mean they have single bond. All right, the bond that hold them, it is what we call a sigma bond. All right, a sigma bond is a front way overlapping of orbitals. By this I mean, if you have carbon to carbon like that, the bond overlap, the bond is between here, so it's side to side. All right, and unlike pi bonds, which happens in the sideways. All right, so the pi bond will be bonding like this. All right, if we have a triple, so have 1 2 3 like that. But if it's a single bond, you just have C and C, and this is what we call a sigma bond. All right, so we are about to know chemistry. We have started chemistry too, and we need to prepare ourselves that we'll meet a lot of things. So it's important that I bring these as simple stuff, whereby we'll be able to what, to recall them. I'll be repeating them like in whatever I say, in all most of concept. All right, so we said they are saturated. By this, they are more like stable. They are only having one bond. So saturated meaning they are only having one bond. All right, with them, so they are saturated like that. You get the point. If they are unsaturated, meaning they are unstable. Master it like that. So that is it. And for so those things are cyclic. Let's say this is, let me just give a propane, so I'll put the H there. All right, like that. Okay, so H H H H H H like that. So we can name is as what, as the propane like that. We know how to name, or the lesson is there, the video on how to name. We saw that. You can go and watch in the channel. All right, YouTube channel. So that's the propane. So this one is what we call a cyclic. All right, it's not in a cycle. Okay, but if we bring in the issue of cyclic now, all right, so if it's cyclic, we'll join this carbon there, carbon there, carbon there. All right, so they can form. So cyclic will start at 3, or propane, or just the prop number of carbons. All right, so this, okay, so we can present like that. So these are hydrogen. All right, so carbon always should be bonded to 4 things. This should be in your mind. All right, so whenever I'll be doing a lot of things, carbon, so these 4 are cyclic. They obey the same general formula, which we said Cn H2n plus 2 like that. But for these guys now, they will obey the formula CnH2n like that. You don't add a 2 because a 2 will be removed for this case on the sideways. The carbon which was supposed to be left out, there will be another 2 there, and also at the end, of which these things should be used to bond to each other and make a cycle like that. So don't forget, master that. All right, so that's about the general formula for cycloalkanes. We are just here to know these things. I'm not here, I'll be trying to say there's exam standard here, pay attention. All right, so there will be exam standard there, pay attention. That's what I'll be telling you. So I'll be telling you, I'll be saying where possible, where it's necessary to pay attention. So a cycle can be branched or unbranched. Okay, so we are saying these acyclic can be branched or unbranched. So let's say this is acyclic. All right, okay, so this is acyclic of what? Butane. So this is the same acyclic. I can also, it can be branched or unbranched. So this is branched, this is unbranched. But if I want to branch it, I'll say, all right, so I'll put another carbon there. You get the point? So there are hydrogens there, there are hydrogens. Okay, so there are hydrogens wherever I put this to my dash. All right, so from there, then this means that it's branched. Okay, we can see a branch of methyl there. All right, so it's a branched alkane. All right, okay, so for even the same cyclic, they can be branched or unbranched. So the branched one, the unbranched one, are the normal alkanes we have been studying since our secondary levels. All right, so I can have a lot of things, let me say. All right, so those are what you call branched and unbranched. Okay, so what if now I say, what if I give you to say this is C? We are just here to know about what? These guys. Okay, so again I give you to say, okay, like this. So let me say wherever I put the dash, that's know that that's a hydrogen. All right, okay, so you should be showing hydrogen in your study, in your answering, in your study. You get the point. So now these ones, this one we can call it a methyl. We know a methyl is just one carbon with the 4 hydrogen. Then this one will be what? Ethane. All right, then this one, how many carbons? 1 2 3 4 5. That is just C, propane. So these are unbranched alkanes, so they're just normal alkanes. So this combination of these families in the same family, which is alkanes, and we have different structures, I mean groups or just names of alkanes, then the format here will be called homologous series. So homologous series are just series of the same family. All right, different members of the same family. So the family is alkane, then they have different names of methyl there, methane, by the way it's methane, then we have ethane there, we have propane, like that. Okay, so each member differ by just a number of carbons, then that should be homologous series. So let's look at these. So these homologous series, or these just members, you can present them in different ways. So you choose, the choice is yours. Let me take propane to be one of our example, right? So if I take propane like this, all right, let me say propane, this is propane with me. All right, so this is a propane with me. How do I can present in different ways. So the first one is chain ways. Okay, chain way. All right, so it can be unbranched, it can be branched. It's always unbranched for propane, because you can't put the group or the substituent. So what we do is, I can write in the form of this presentation, which is which we have been studying and we are most familiar with it. So this one is also one way of presenting what the propane. So the other way I can present propane is by saying, okay, by using what we call now, okay, Kure structure. Kure is the situation whereby I put this. So where here it's a number of, at each point, or each point is a number, or just each corner, it's a number of carbons. So you have 1, 2, 3 like that. Okay, so that's about it. The other way I can present this propane is by writing dash wedge presentation, where I can say this is carbon, all right, again this is carbon, again this is the carbon, like that. So I will be always getting what, let's say I put hydrogen there, then the 2 hydrogen I'll put dash and the wedge. All right, so these ones they are just the different ways of presenting us these alkanes. All right, you choose, the choice is yours. All right, okay, so the choice is what is yours. Okay, so there are no restrictions. Okay, there are no restriction on the way of presenting these alkanes. So this is what we call now dash wedge presentation. So let me say, can you present alkane, methane? So we will do the same. 2 hydrogen that are what, that are having the same, 2 hydrogen should differ by wedge on each carbon. All right, so these you put dashes like that, then this a board wedge like that. So I put hydrogen like that, then these 2, they'll be just, let's say this is a propane, I mean a methane, this is again a methane. All right, so you just choose, you can present it like the other way I can use is Newman projection. So Newman projection would be, let's say we have this carbon there. All right, so I eject it to what, this carbon, then this carbon I light it to say it has CH there. All right, so I'll get these 2 and present what I need. So what I'll do is I'll put, this is hydrogen, this is hydrogen, and this is hydrogen. You get the point? So also here I'll put that is hydrogen, and also that is hydrogen. Okay, so from there, then now this is now my point of interest. So this is the point, then I'll put these things that I have, these groups. So I'll put like that, like that, like that. So I'll put this hydrogen there. All right, for this carbon here. All right, so this is what we call Newman's projection, but the topic is there in isomerism. That's when we do this isomerism. Hope you will be a part of us. So what you do here, you say, you present now by saying you write this carbon which is there. All right, you write it like this, you bring it now outside the circle. Okay, so follow the way you found those what, those methane. So the other methane was here, somewhere here. All right, so that was the methane which was there. For this carbon is the one that you can't see, it's outside there. So what you do is now you bring another hydrogen there, again you bring another hydrogen. Okay, suppose this hydrogen was somewhere here, so you get the way you found them on the plane. Okay, so on the plane, on the paper, something like that. So this is how, what we call a Newman projection. Newman projection, like that. Okay, so that's how we'll be presenting these alkanes in different ways. So for branched one, I said it's a situation whereby you have a branch there, then you'll be able to see, let's say this is branched, I'll put something like an alkane again here, meaning it's a branched one. You have branched another guy, so even naming should not be let me talk about branched alkanes. All right, so master, the choice is yours to present these guys. So it's about which one you are comfortable with. Okay, so it's about which one you are comfortable with. So can I just give you to say, let's say we have C, or I just give you N. Okay, this is a butane. Again I have, let's say C, this is the propane. Then I give you to say C, like that, C like that. Okay, so let me just make one compound. Okay, I just make butane, all of them. All right, so this butane now that I have, All right, so I'll want to present butane in different ways, and I'll be just changing the positions. All right, so what I would do is I'll say the first butane will be just like this, then the second butane will be just like this. All right, the third butane will be just like this. All right, or I can just write another structure, just different structure. All right, so what I'll do is this is all butane, right? 1 2 3, they are all butane. Okay, so not really butane, this one is a butane, and also is a kind of butane though with a different name. So these compounds that have the same molecular formula, by the way, so 1 2 3 4, 1 2 3 4, 1 2 3 4. So let me lab that one. All right, just like that. So these compounds that have the same molecular formula but differ in connectivity, like the way we see here, they differ in connectivity, we call them constitutional isomer. They constitute different positions. All right, so we call them constitutional isomers. All right, so very important term to master, constitutional isomers. All right, so since they are constitutional isomers, so they differ in the connectivity. So all these are constitutional isomers. All right, so these are constitutional isomers. Okay, so example, let me just give you an example. Say write a possible constitutional isomer for, let's say what compound can a propane. All right, propane will have a 12 there. So propane, you light 1 2 3 4 5, 1 2 3 4, 1 2 3 4, like that. So you can bring the 5 one. So this one is just normal, this is correct, this is propane. Now this is the first connectivity. The second one I'll put here. So this is the what? Third connectivity. Just like that. I'm sure it will have just 2. If I put here, it will be just the same. All right, so I'll say, let's say it has 2 connectivity, so I'll put this guy here, all right, as the branch. So 1 2 3 4 5, which is making now a different name, but is still a propane under basic naming. All right, so this different connectivity but same molecular formula, we call it constitutional isomer. They constitute different positions or grouping or just structures, but they have the same formula. All right, so we are going to have 3 of them. Yeah, so the carbon we are seeing to be grouped can be classified as this one, this carbon you're able to see here. It can be what we call tertiary, I mean primary, which is 1 degree, then secondary, which is 2 degree, then 3 degrees what? Tertiary. All right, so there is also quaternary, but we won't be talking about it, all right, in our study. So even hydrogen, the same hydrogen, if a hydrogen is bonded on the carbon, so the carbon that will be bonded to one carbon is what we call a primary carbon. Let's say this is a primary carbon, it's bonded to one carbon. So the carbon that will be bonded to 2 carbon, okay, so this carbon is what we call now a tertiary carbon, which is a secondary, which is 2 degree. Then a carbon that will be bonded to 3 things like that, to 3 other carbon, will be called a tertiary with a 3 degree there. The secondary then you to be bonded to 4 carbon, like that. You get the point. So now these are what we call degrees of carbon, or degrees of carbon stability. So even the stability will matter just like that. Okay, so that's about it. Even the hydrogen that will be bonded, let's say the hydrogen is bonded to the carbon that is just primary, so this carbon is primary, so the hydrogen that we will find is also primary. So if another carbon is bonded to 2 things like that, this carbon is what? Secondary. So even the hydrogen that we find on the secondary, they are called secondary hydrogens. All right, so that is it. Okay, so we are just here to know these things. Don't get tired, guys. These are the things that we need to understand. So we need to understand these things, by the way. So it's a lesson on its own, and it's a lecture note. You are like that, you are receiving these lessons free. Your friends do pay, okay, but we are giving you for free. What you want is just you to subscribe. That's all. So there's now we can talk about there are what we call our Q groups. All right, those groups that we saw, they are branched or they are classified as well. So the groups that we'll be using, let's say I have carbon there, carbon there, carbon there. So I can have a group that is let's say I have a straight chain like that. Okay, then this group is also branched with this as well. All right, or just so these are groups. All right, we have this ala, which is this bond, then the group now with what, another two groups there. All right, all right, so we are talking about now our Q group. So it's an alkane, but as a group it will be called our Q. All right, so that's now what we want to look at. So there are different groups and we need to know them. All right, so the first group, if you find just C bonded to a straight thing or just to a longest chain, that will be called a methyl. All right, so a carbon that will be bonded to a certain group, then it's a carbon like that with 3 hydrogens. All right, so this is called a methyl. All right, a group is called methyl. Then what about another thing where we have, let's say, a carbon there bonded to another thing, let's say ala, where ala is the main chain, then we see another carbon here to this carbon we have there. All right, so this will be called what, ethyl, because it's two carbons, so it will be called ethyl as a group. All right, so it will be called ethyl as a group. So we'll talk about naming. So here for now just know the basics. All right, so what about now if we have 3? All right, so we can have carbon with just the carbon, let's say. So this carbon is bonded to what, to 3 carbons. All right, okay, so this carbon and it's branched like that, you get the point. So it has 1 2 3 4, there are 4 of them. So if there are 4 of them, we'll call this as what, we'll call this as the, let me lab this one so that I follow the pattern. Let me lab this one. All right, so let's say this is now ala, which is our group. So there are 3 carbons, so we call this propyl. All right, so it will be called a propyl as a group when we have propane. Okay, so the other thing that we can talk of is, let's say now we have this group ala is always the longest chain where it is attached. All right, so we get to have something like what, all right, so this is a group, this is a group, I guess. So there are how many carbons? 1 2 3 4. All right, so this will be what, a butyl. All right, no, they are given a proper name, since now it has it's more like it is made of this, you get the point. So when you see a structure like this is ala, by the way. So when you see like this is what we call now isopropyl, because there is 1 carbon there, 1 carbon there, 1 carbon, so it's a propyl. So by the age of making a mouth or a smile, we call it isopropyl, or okay, isopropyl. Instead of propyl, just we call it now isopropyl. So that should be the same case. So isopropyl or just propyl is the same thing. So they are just special names that we should be using whenever we meet. So what if now again, let me present it in Kekule form. All right, so another carbon there. All right, so here there is 1 carbon, there's 2 carbon, 3 carbon, 4 carbon. So meaning that this is a what, we'll call it, it was supposed to be butyl, but I'll just call it tet butyl. All right, just to know a special name. It's a special name and we have no deal about it. So it can be a butyl or tet butyl, but the way they are branched, a butyl will only be if it's a, we have a longest chain like that, let's say containing 12 carbons. All right, then we bring now the 4 carbons, then those will be called a butyl. All right, but in a situation whereby they are branched like this, we call it a special name to say tet butyl, just like we saw for isopropyl. is if it's straight, we call it what? Propyl. But if it's branched in that way, we call it what? Isopropyl. So that is it. So that's how we'll be calling these branches. So these are enough for you. Let's talk about just the IUPAC of alkanes. Some alkanes, I won't talk about them, a lot of them. We already know the basic alkanes. I mean how to name them. The lesson on its own will be there on how to name alkanes. Alright, so we'll talk about its own lesson on how to name alkanes. Okay. So whenever you are naming alkanes, always consider a longest chain. So let's say I have carbon like that. All right, so then I have another carbon like that, then I continue like that. So I can't start naming to say 1 2 3 4. All right, by the way, let me do this, or just let me just okay. So these are what? Number 4. But if I start from here, I'll say 1 2 3 4 5. Okay, so this will be my longest chain. So my first priority of naming will be following this. All right, so since I'm following this now will be a group. So this is the best way. You always consider the group, I mean the main group or the chain group, then you follow. Now you give the at least the priority of what? Bringing the substituent as a group with the lowest number. So that those are the things. Let's say I give you to say this is C again, C like that. Okay, 6 of them. Okay, so since now this is a hexane in actual sense, so what I'm going to do is let me put some branch. Let me put a branch there, C. Again here I put a C. All right, let me just put double C there. Then here again I put a C. All right, then here, okay, just like this. So naming a group should always receive a number. You follow. So the longest chain is 1 2 3 4 5 6. Even going this side, 1 2 3 4. I mean the longest chain is now 1 2 3 4 5 6. Even just naming to say even if I can light 1 2 3 4 5 6. You get this way, but this way it will give me the highest number, which is not good, of a substituent like that. So I don't want that situation. Instead I'll start numbering. I can also start numbering from here to say 1 2 3. All right, 4 5 6. You get now. So this is also another way of numbering. Now the group again will receive a number at 3. All right, at 3. Now we don't want this situation. So what we want is we want to see that a group has received the lowest number, the first group at least, which is just to the lowest number. So I will start naming from here. 1 2. All right, 3 4 5 6, like that. So since these are the things I have, now I can start now numbering. Always you should follow the alphabetical order, the way you name them. So since number 3 is what? An ethyl group. All right, so this is an ethyl group. All right, then number 2 is a methyl. All right, number 4 again is a methyl. All right, so what I'll do is I'm following the alphabetical. M is later than E in the alphabetical order. So what I'll do, I'll say 3. All right, 3 ethyl. We always separate a number with a word. All right, so 3 ethyl like that, dash, you bring now 2 and 4. They are having the same methyl, so 2 comma 4. Since there are 2 methyls, I'll say dimethyl. All right, so they are dimethyl like that. Dimethyl what is the name of this? It had what? 6 carbons, so that would be hexane, dimethyl hexane. All right, so that would be the numbering. So for this example, I'm sure it has summarized a lot of things, so hope we are getting there. This is 260, guys. This is 260. Okay, So that is 260. This is 260. So don't get confused. We are just here to know these things. So naming of cycloalkanes will be just very simple. Let's say I give you this. All right. So this is a propane. There's one carbon there. There's one carbon. So you name to say you just add the cyclo at the end. So this is cyclopropane. All right. It's a propane. So you just put, since it's a cycle, you just put cyclo. Okay. So if I give you to say all right. So you count the number of carbons. 1, 2, 3, 4, 5, like that. So this is a propane in I mean it's a pentane in actual sense. So since this is a pentane, so you just put cyclopentane like that. Okay. So again, if I put you, I mean I give you like this to say name this, you name by saying how many, 1, 2, 3, 4, 5, 6 angles. So you say this is the cyclo. Since it's a cycle, you say cyclohexane. Hexane is a sixth angled thing. Okay. So that's cyclohexane. Then these things again, they can be branched. So let's say we put a branch there, methyl. All right. So again, I put, let's say, a branch there. Or let me just start with the same branch. So you just name the way they are. So this is methyl. You start. You can actually start numbering from here, and you reach 6 here. All right. So since you are doing this, then you say 1. All right. Or just say methyl cyclohexane, or 1 methyl. Okay. Cyclohexane, like that. Okay. So again, if we were to bring those things we were considering, I mean the special groups or alkyl groups, let's say I give you to say a certain what. So it's a propyl in its own, but it's branched like this. I mean it's a propane in its own, but being a special group, it will be isopropyl if you see like this. So you say now you name this as what? Isopropyl. Isopropyl, then you bring the structure, which is the cyclo what? Hexane. All right. So this is how you'll be numbering. So if suppose again I put another thing here. All right. This is a butyl, right? So you start numbering to say, we know that this is what iso. All right. This is what tet. Which one comes first in the alphabetical order between S and T? I mean I and T. Which one comes first? All right. So we can see I'm sure T comes later. So what we'll do is we'll go on ISO. So you name to say on position number 1. So this will be position 2, 3, 4, 5. So on position number 1, we'll say ISO. We'll consider ISO. So we'll say 1 ISO. All right. So you say 1 ISO. 1 ISO. Propyl, then dash, you put now 5 tet butyl. All right. Butyl cyclohexane. You conclude like that. Okay. So that's how you'll be naming these cycloalkanes. They can have branches, but we need to know the special branches, I mean special groups. So these alkanes, they have the properties. So there are some properties of these alkanes. We can't just be studying something do not have a property. How are we going to be, I mean, identifying them if they don't have property? So what you need to know about alkanes, alkanes, they are non-polar. By this I mean, like, if you calculate the difference in electronegativity of these two, I mean, yeah, they will always give, let's say this is having 2.1 and this is 2.1 for hydrogen, let's say. So once you subtract these two, the difference will give you 0, which is non-polar. All right, non-polar, we said, ranges with an electron electron difference of what? Of 0 to 0.4, like that. I remember this in our first year we did this, guys. So they are non-polar, by the way. So these are the just characters or properties of what? Of alkanes. So one, they are non-polar. All right. So non-polar. Okay. So we just have to know that they are non-polar, so they have, meaning that they have weak van der Waals forces. The other thing that we can say is these guys, they increase in boiling point as their branches increases. All right, so as you increase the number of groups, you are increasing the surface area, meaning that the boiling and melting point will increase as well. All right, as you increase the branch, you are now reducing the surface area. So if I continue like this, I'm increasing the surface area. So as the number of chain increases, then the boiling point and melting point increases. All right, so they increase because you are increasing the surface area. But in a situation whereby you are increasing the branches, you are reducing the surface, more like you are working on the same place, you just maintaining, I mean, the diameter. So meaning that you are now reducing this boiling point and the melting point, like that. Okay, so they'll be reduced because we are reducing the surface area. Okay, so that's about alkanes, guys. See you in the next video where I'll talk about conformation of cycloalkanes. All right, so that is it about alkanes. We need to know just a few properties, and also we have talked the basics of alkanes, and it's important that you have at least listened to the, hope you have taken some notes. Thank you very much for watching the video. See you in the next video where I'll be talking about the conformation of cycloalkanes specifically to be butane, and also see some presentation of some conformation where it will be a nice thing. Hope you join them. So this is what we have covered. Know that for cycloalkanes and alkanes lecture note, you have summarized everything in this just video. Make sure that you watch the video. Thank you very much.